Hello children, I am Ekta. Today we are going to learn about polygons. Children, do you know that a quadrilateral is basically a type of polygon? And there are different types of quadrilaterals that are classified on the basis of their properties. Have you seen a kite fly in the sky? Well, its shape is also a quadrilateral. So, let's focus on understanding quadrilaterals and their types with properties. After the completion of this lesson, you will be able to know learning objectives: to understand polygons, to understand the types with properties of polygons, to understand the angle sum property of polygons. Keywords from this lesson: polygon, regular, irregular, convex, concave, quadrilateral, angle, straight line. Children, polygon is part of our everyday life. We use things which are in any form or shape. Most of them are polygons. In this chapter, we will explore elaborately about polygons and their types. Let's see, what is polygon? A polygon is two-dimensional shape formed with more than three straight lines. For example, a closed figure formed with three straight lines has termed a triangle, whereas a shape formed with four straight lines is known as a quadrilateral. It is formed with only straight lines. If any curved line is used to form a closed figure, then it will not be termed a polygon. Polygon is basically any closed shape which is formed with three or more straight lines. There is no limit to how many sides will be there in a polygon. It can possess infinite sides, and they can have 10 sides or more sides. Types of polygon. A polygon can be classified on the basis of the number of sides and measure of angles. First, we will discuss the basics of the measure of angles, classified by measuring the angles. Regular polygon. A polygon in which all the sides of the angle are the same and all the interior angles of the polygon are equal is called a regular polygon. Irregular polygon. The polygon which is not regular a polygon is known as irregular polygon. Irregular polygons do not have equal sides and measures of angle. Convex polygon. The polygon whose measure of an interior angle is less than 180 degree is termed a convex polygon. The vertex of a convex polygon are always outwards. Concave polygons. In concave polygons, at least one angle measures more than 180 degree. Those polygons which are not convex are concave polygons. Quadrilateral polygons. Quadrilateral polygons are polygons which are four-sided or with four angles, that is quadrangle. Every polygon which forms four angles is known as a quadrilateral polygon. Pentagon polygons. The polygon which consists of 5 sides is termed a pentagon polygon, classified by measuring the sides. The name of a polygon is termed according to the number of sides they have. Triangle. The three-sided polygon is known as the triangle. Quadrilateral. Any figure which is a closed four-sided figure is known as a quadrilateral. Pentagon. The closed figure which is formed by 5 straight lines is known as a pentagon. Hexagon. The 6-sided polygon is known as a hexagon. Heptagon. The polygon with 7 sides is termed a heptagon. Octagon. As the name says, the 8-sided polygon is known as octagon. Nonagon. The polygon which possesses 9 straight lines is known as a nonagon. Decagon. The closed figure made with 10 straight lines is termed a decagon polygon. The most common type of polygons is triangle, rhombus, kite, trapezium, etc. With the above details, it will now be easier for you to determine the shapes. We already know that a simple closed curve that is made up of more than 3 line segments is called a polygon. Every polygon has a set of angles that are result of the line segments involved in the closed figure. In the chapter below, we shall learn about the angle sum property of polygons, which indirectly depends on the number of sides in that polygon. Angle sum property of polygons. We have learned about the angle sum property in triangles. According to the angle sum property of a triangle, the sum of all the angles in a triangle is 180 degree. Since a triangle has 3 sides, we find the measurements of the angles accordingly. Let's recap the method. For example, if there is a triangle with angles of 45 degree and 60 degree, the third angle is unknown. For finding the third angle, we follow the given system of calculation. A plus B plus C is equal to 180 degree. A is equal to 45 degree. B is equal to 60 degree. C is equal to question mark. 45 plus 60 plus C is equal to 180 degree. C is equal to 180 degree minus 105 degree. C is equal to 75 degree. So, the third angle is 75 degree. Using the above shown system of calculations, we can find out the unknown angle in a triangle. But what about a polygon? Similarly, according to the angle sum property of a polygon, the sum of angles depends on the number of triangles in the polygon. According to the angle sum property of polygons, the sum of all the angles in a polygon is the multiple of the number of a triangles constituting the polygon. We use the angle sum property of triangles while calculating the unknown angles of a polygon. Relation of angle sum property of triangles and polygons. When we analyze a polygon, we come to know that it is a compilation of many triangles. Let's see how. Take a polygon and draw diagonals that divide the structure into triangles. The number of triangles formed from the division give us the idea of the total sum of angles in a polygon. See the figure below. In the figures above, A is a hexagon while B is a pentagon. Hexagon, when divided into diagonals, constitutes 4 triangles. The sum of the angles in a triangle is 180 degree. This means that the sum of angles in a hexagon is equal to 4 into 180 degree, which is 720 degree. Similarly, in figure B, which is a pentagon, the number of triangles constituting the shape is 3. So the sum of angles in a polygon shall be 3 into 180, which equals 540 degree. Likewise, for a heptagon, the number of triangles formed after dividing into diagonals is 5. Hence, the sum of angles in a heptagon shall be 5 into 180 degree, which equals 900 degree. In the above discussion, one thing worth noting is that the number of angles is equal to number of sides minus 2. So, for every polygon with x number of sides, the number of triangles is 2 less than the number of sides. Polygons can have any number of sides greater than 3. And when we find the sum of angles in a polygon, we study the number of triangles constituting the closed shape. It is only after the study of the number of a triangles we can find the sum of angles in a polygon. Points to remember. A simple closed curve that is made up of more than 3 line segments is called a polygon. The angle sum property of polygons, the sum of all the angles in a polygon is the multiple of the number of triangles constituting the polygon. The number of angles is equal to number of sides minus 2. So, for every polygon with x number of sides, the number of triangles is 2 less than the number of sides. Thank you for watching this video.